Welcome back to our deep dive into computer science.
Hmm.
We're continuing our exploration of computer science and software engineering, and today we're going to be taking a look at something called answer set programming.
ASP.
ASP,
Okay.
which is a
Yeah.
pretty fascinating approach to problem solving, and it kind of shakes things up compared to how we usually think about programming, doesn't it?
Yeah, it really does. Instead of giving the computer, step-by-step instructions like we do in traditional programming, ASP is more about describing the problem, sort of defining the rules of the game, and then we just let the computer figure out the solution on its own.
So we're basically giving the computer a puzzle and letting it find the winning moves.
That's a great way to put it. Yeah. It's all about defining the what problem we want to solve, not the how, not the specific steps to get there. And this makes ASP especially good at tackling these problems that are known as NP-hard problems.
Oh, yeah.
Yeah.
NP hard problems. These are the ones that even supercomputers can struggle with.
Exactly.
Right, where you might need to try out just tons and tons of possibilities before you find the best solution.
Yeah, exactly. Like things like optimizing routes or scheduling complex tasks or even like breaking encryption. These problems where finding the best solution can be like searching for a needle in a haystack.
So how does ASP manage to find solutions to these really complex problems if it's not following step-by-step instructions?
Well, this is where it gets really interesting. ASP relies on this concept of stable models.
Okay.
And you can kind of think of these stable models as the, best fit solutions to the problem. Solutions that don't have any contradictions and that perfectly match all the rules that you've defined.
Okay, that makes sense. But how does the computer actually find these stable models? It's not just randomly guessing, is it?
Not at all, no. It uses special programs called solvers to do the heavy lifting. And these solvers, they act like incredibly smart search engines that systematically explore all the possible solutions using, very clever algorithms to find those elusive stable models.
So it's kind of like having a team of expert puzzle solvers all working behind the scenes for us.
Yeah, exactly. And what's really remarkable is that unlike some other approaches, ASP solvers, they're actually guaranteed to eventually find a solution if one exists. They won't give up until they've cracked the puzzle.
And to use these solvers, we need a language to describe the problem and its rules. And that's where ANSProlog comes in, right?
Right.
ANSProlog. I've heard that name before. What's its connection to ASP?
So ANSProlog, which is short for answer set programming in logic, it's actually the most popular language for writing ASP programs. And it provides a way to express the problem and its constraints in this sort of logical format that the solvers can understand.
So if ASP is the framework, then ANSProlog is the language that we use to write the instructions for the computer.
That's a great analogy, yeah. In ANSProlog, we define rules that often look something like this. This is true if that is true. It's a very logical and straightforward way to express the relationships between different parts of the problem.
So are there any features in ANSProlog that make it especially powerful for ASP? Because it sounds like it's more than just simple if-then statements, right?
You're absolutely right. ANSProlog has some really neat features that make it incredibly powerful for ASP. One of these features is called choice rules.
Okay.
And with choice rules, you can essentially give the computer a set of options and then let the solver choose the best one that fits within the overall solution.
So it's almost like we're giving the computer a multiple choice quiz, but it has to figure out the right answer based on all the other information available.
Exactly, yeah. Another cool feature is called cardinality bounds.
Okay.
And this allows us to set limits on how many of certain things can be true at the same time.
Oh, interesting.
Yeah. So, for example, we could say at least 2 of these statements must be true, or no more than 5 of those can be true. It gives us a lot of control over the types of solutions that we're looking for.
It sounds like ANSProlog offers a lot of flexibility in how we can define the problem.
Mm-hmm.
Are there any other tricks up its sleeve that make it easier to work with?
Absolutely. So ANSProlog actually uses variables, just like you'd see in other programming languages. And these variables act as placeholders, allowing us to write, more complex rules without repeating ourselves over and over again.
Variables, those trusty shortcuts. So it seems like ANSProlog is all about simplifying how we express really complex problems.
You've hit the nail on the head. And there's more.
Okay.
We can also use ranges to define sequences of numbers, which is incredibly useful when working with problems that involve numerical values.
That makes sense. But what happens when the rules themselves depend on certain conditions being met? How do we handle that kind of complexity?
Well, that's where conditional literals come into play, and these allow us to make the rules even more flexible.
Okay.
We can basically say, this rule only applies if this other condition is true.
So it's like adding a built-in if-then statement to each rule.
Exactly, yeah. And all of these features, they work together to make ANSProlog very expressive and very capable language for defining, even the most intricate problems for ASP to solve.
Okay, so we've written our ANSProlog program, which is basically our set of rules and constraints for the problem. So what's the next step? How do we actually get the computer to start working on it and finding those stable models?
Well, that's where the ASP solvers that we talked about earlier come in. So we take our ANSProlog program and we feed it to a solver. One popular choice is a solver called SMODELS.
Okay.
And then, well, we wait.
So it's like hitting the go button and letting the solver loose on the problem that we've defined.
Exactly, yeah. And the solver analyzes the rules and constraints and explores all the possibilities. And eventually, boom, it presents us with the stable models, which are the solutions to our problem.
This is where it gets really exciting for me because we've talked about the theory, we've talked about the tools, but how does this all play out in the real world? Can you give me some specific examples of what ASP can actually achieve?
Absolutely, yeah. One of the classic examples is graph coloring. So imagine trying to color a map so that no two neighboring countries have the same color.
It sounds simple enough, right?
It sounds simple, but I imagine it could get incredibly complicated, especially if you have a map with like hundreds or even thousands of countries. I mean, trying to do that by hand would take forever.
Exactly. And that's where ASP shines. We can define the problem in ANSProlog, outlining all the countries and their borders and the available colors, and then let the solver find the most efficient way to color the map.
Wow, that's amazing. It sounds like ASP can handle tasks that would just take humans ages to solve.
Yeah.
What other real-world problems can ASP tackle?
Well, ASP is also incredibly good at finding something called clicks in networks.
Clicks, like in high school. Well, not exactly. I mean, the concept is kind of similar, but in network theory, a clique is basically a group of nodes where everyone is connected to everyone else. So think of a social network. A clique would be like a group where everyone is friends with each other.
Right, and finding these cliques can be useful in all sorts of areas, can it?
Yeah, definitely. It has applications in social network analysis, biology, marketing, even crime investigation.
So ASP is starting to sound like a real Swiss Army knife for problem solving. What else can it do?
Another great example is the classic traveling salesperson problem.
Okay.
And this is about, finding the shortest route that visits every city on a list exactly once. It's also known as a Hamiltonian cycle.
Oh, I remember that problem. That's one of those that can really make your head spin.
Yeah, it can definitely be tricky, but ASP handles it with ease. We just define all the cities and the distances between them, and then the solver finds the most efficient route. And this, could potentially save time and money and fuel in real-world applications.
I'm seriously impressed. But we're talking about computer science, so I have to ask, can ASP help us understand language itself?
Great question. And ASP is indeed making waves in natural language processing. It can be used for something called dependency parsing, which is like diagramming a sentence to understand, all the relationships between the words.
So it's like having a computer that can analyze grammar and really grasp the meaning of sentences.
That's a good way to put it. Yeah, it's a very powerful tool, and we've really only just begun to explore what it can do.
I'm completely hooked. I can't wait to learn more about the world of ASP and what other amazing things it can accomplish. Stay tuned, everyone, because we'll be back soon with more insights and examples in part 2 of our deep dive into answer set programming.
Welcome back to our deep dive into answer set programming.
I'm excited to hear more.
Yeah.
When we left off, we were talking about some of the ways that ASP is being used to solve real-world problems. And you mentioned that you had even more examples of how this pretty unique approach is being applied across various fields. So what else is out there?
Well, let's venture into the world of bioinformatics.
Okay.
Which is a field that is just bursting with data, as we delve deeper into the mysteries of life. And ASP is becoming, an increasingly valuable asset for researchers who are working with all this biological data.
How is ASP helping researchers unlock the secrets of biology. That sounds like a pretty big leap from coloring maps to analyzing genes.
Yeah, it is a fascinating application. One area where ASP is really making a difference is in the analysis of gene regulatory networks.
Okay.
So imagine like a complex web of interactions between genes where the activity of one gene can directly influence the expression of others.
Right.
And understanding these networks is absolutely crucial if we want to understand how, cells work and how diseases develop.
It sounds incredibly complex.
Yeah.
How does ASP even begin to make sense of these intricate interactions?
Well, researchers are using ASP to create models of these, complex relationships. They essentially translate what we already know about gene interactions into rules written in ANSProlog.
Okay.
And then they use those powerful ASP solvers to pinpoint stable models. Remember those?
Yeah.
And the stable models, they represent potential regulatory mechanisms within the network.
So ASP is kind of helping scientists navigate this very complex world of biological data by finding those stable, consistent patterns.
Exactly. Yeah. It's like having a superpowered detective who can sift through a mountain of clues and identify the most likely scenarios for how these genes are interacting.
And that can lead to all sorts of amazing breakthroughs about how genes function, how diseases progress, and even how we might develop new therapies. That's incredible. It's really amazing to see how ASP can kind of bridge the gap between computer science and fields like biology, and leading to real-world impact. But real-world data is often messy and incomplete. Can ASP handle problems that involve a degree of uncertainty?
You've hit on a very important point and a really exciting area of research, actually, within the ASP community. So researchers are working hard to extend ASP so that it can handle something called probabilistic reasoning.
Okay.
Which means, incorporating uncertainty into the equation.
Probabilistic reasoning. So instead of dealing with absolute truth, we're talking about probabilities and likelihoods.
Yeah.
How does ASP adapt to that kind of what sounds like fuzzy logic?
Yeah, it's a real challenge, but researchers are developing extensions to ASP that allow for probabilistic rules and facts. So instead of saying, this is true, you can say, this is true with a 70% probability.
That sounds like a much more realistic way to model many real-world problems where we often don't have, all of the information or complete certainty.
Right, and these probabilistic ASP frameworks, they allow for much more nuanced reasoning.
Okay.
So we can start, asking questions like, what is the most likely scenario given the evidence that we have? Or what are the chances of, this particular event happening?
Yeah, I can see how that would be incredibly valuable in fields like medicine or finance or even weather forecasting, where we're dealing with probabilities is just it's a daily reality.
Absolutely. Yeah. Probabilistic ASP is still, relatively new, but it has immense potential for tackling a wider range of, real world problems that involve uncertainty and risk.
So far, we focused on how ASP is applied to fields like biology, but can it be used to solve problems closer to home, problems that we face in our everyday lives?
Of course. Let's talk about something that everyone can relate to, planning and scheduling.
Well, that's definitely something I struggle with. Juggling work deadlines and social events and personal commitments, it's a constant challenge. Can ASP really help with that?
Yeah, it certainly can. So imagine using ASP to create like a personal assistant that could optimize your schedule for you. You would provide all the constraints like your work hours, your appointments, your preferred free time, and so on. And then the ASP solver could generate, a schedule that maximizes your productivity and minimizes those dreaded schedule conflicts.
That sounds amazing. No more double booking or last minute scrambling. But can ASP really handle all the constant changes and unexpected events that pop up in real-life scheduling?
Well, that's where things get even more interesting.
Okay.
Researchers are actively working on making ASP more adaptable, so it can handle dynamic environments. So imagine, rules that can actually adjust to new information and events as they occur, rather than relying on a static set of instructions.
So it's like having a personal assistant that can think on its feet and adjust the plan on the fly. Where do I sign up?
We're not quite there yet, but this type of dynamic ASP is a very active area of research with huge potential. So imagine, the possibilities for real-time scheduling, resource allocation, even robotics.
Okay, I'm starting to feel like ASP is is the answer to all of life's problems. But seriously, though, this declarative approach to problem solving seems incredibly powerful and versatile.
It really is. And the beauty of it is that it lets us focus on defining the problem without getting bogged down in the how, figuring out every step of this solution. We leave the hard work of finding those elegant solutions to the ASP solver.
It's like having a team of brilliant minds working tirelessly behind the scenes, sifting through all the possibilities and presenting us with the most efficient answers. And this power is it's accessible to anyone who takes the time to learn the language of ASP ANSProlog.
Yeah, you got it. And as ASP continues to evolve, we can expect to see even more innovative applications emerge, tackling even more complex problems across a wide range of fields.
This deep dive into answer set programming has been really enlightening, but I feel like we've only scratched the surface of this fascinating world. Welcome back to the deep dive.
Yeah.
We spent the last 2 parts exploring this fascinating world of answer set programming, kind of uncovering its unique approach to problem solving and its really remarkable applications. But like with any powerful tool, it's essential to understand its limitations too, isn't it?
Yeah, you're absolutely right. ASP isn't a magic bullet for every computational challenge out there. It definitely has its strengths, but it also has its weaknesses. And it's really crucial to select, the right tool for the job.
That makes a lot of sense. So what are some of the limitations of ASP that we should be aware of? When might it not be the best choice for tackling a problem?
Well, one key factor to consider is just the sheer, size and complexity of the problem. ASP really shines when we're dealing with problems that involve searching through a huge number of possibilities, like those combinatorial problems that we talked about. But if the problem, involves a massive amount of data or incredibly intricate relationships, even, the most advanced ASP solvers can run into trouble.
It's like trying to solve a gigantic jigsaw puzzle, with thousands of pieces. Even with a really clear picture in mind, it can just become incredibly overwhelming.
Yeah. That's a great analogy. Another point to keep in mind is that ASP isn't always the most efficient approach for problems that have a clear, straightforward solution that can be tackled using, more traditional procedural programming. So if you have a well-defined algorithm, that can compute the solution step by step, then sticking with, languages like Python or C++ Mech might be a better choice.
So it's all about choosing the right tool for the task at hand. AST excels when we need to explore a vast search space.
Yeah.
But for problems with clear-cut solutions, more traditional methods might be more efficient. So how does ASP compare it to other programming paradigms? I mean, we've talked about how it differs from traditional procedural programming, but what about other declarative approaches like constraint programming or logic programming?
That's a great question. So while both ASP and constraint programming, involve defining constraints, their focuses are different. So constraint programming is all about finding solutions that satisfy a set of constraints and, often using numerical variables and relationships. ASP, on the other hand, it focuses on finding stable models, which provide like a consistent interpretation of a logical theory.
So constraint programming is more like solving a set of equations, while ASP is more like building a logical argument.
Exactly. Now, in terms of logic programming, particularly Prolog, ASP and Prolog, they both have roots in logic, but they've evolved along kind of different paths.
I remember from some of our previous deep dives that Prolog is all about querying a knowledge base and finding answers based on logical inferences. So how does ASP's approach differ from that?
Well, one of the key differences is in how they handle negation.
Okay.
So Prolog uses something called negation as failure. If it can't prove something to be true, it assumes that it's false. But ASP, on the other hand, treats negation as like a fundamental part of its reasoning, which allows for richer and more nuanced ways to represent knowledge.
So ASP is better equipped to handle situations where we don't have all the information, or where something could be true or false depending on the context.
Precisely, yeah. And ASP's ability to deal with negation in a more sophisticated way makes it, particularly well suited for problems that involve common sense reasoning, where we often encounter exceptions and uncertainties.
So this whole discussion has been really helpful in kind of understanding ASP's place in the world of programming. It has its strengths, it has its weaknesses, like any tool, and understanding those is key. But what about the future of ASP? What exciting advancements are kind of on the horizon?
Oh, the future at ASP is truly exciting. One promising direction is the integration of ASP with other cutting edge technologies, like machine learning and data mining. So imagine combining ASP's logical reasoning with machine learning's ability to find patterns in just vast amounts of data.
That sounds like a really powerful combination. What kind of applications could emerge from this fusion of ASP and machine learning?
Well, imagine using ASP to actually guide the training of machine learning models. Incorporating existing domain knowledge and logical constraints to improve the accuracy and reliability of these models. Or think about using machine learning to actually learn probabilistic rules for ASP, enabling more adaptable and data-driven reasoning.
So it's not just about using ASP on its own, but about kind of weaving it together with other really powerful technologies to solve even more complex problems.
Exactly. Yeah. Another exciting area of development is the quest for more efficient and scalable ASP solvers. As we tackle bigger and more complex problems with ASP, we need solvers that can keep pace.
It's like a race to build faster, smarter solvers that can handle these increasingly challenging problems.
Right. And researchers are exploring, new algorithms, parallel processing techniques, even hardware acceleration to really push the boundaries of what ASP solvers can achieve.
Well, this deep dive into answer set programming has been truly fascinating. We've discovered how this declarative approach is revolutionizing problem solving. Letting us define the what and allowing the computer to uncover the how. We've seen how ASP is being used to solve this wide range of real world problems, from untangling the complexities of biology to helping us manage our everyday schedules. And as ASP continues to advance, we can only imagine the incredible breakthroughs that it'll make possible in the years to come.
It's an exciting time.
So as we conclude our deep dive, we encourage you, our listeners, to think about problems in your own lives or work that might benefit from this declarative approach. What rules could you define for a computer to help you find solutions? Perhaps ASP is the key to unlocking new possibilities in your own field. So until next time, keep exploring, keep asking questions, and keep diving deep.